Okay, guys, I have given you 7.21. It's quite a thick packet. There's a reason for that. I think these problems are really important to give you a real, just kind of a better understanding of really what this unit circle is. I know we jump into the unit circle and we kind of do problems where we have these perfect angles around the unit circle, but we kind of miss all those angles in between and really understanding what happens. And so we lose some of the basic understanding of what trigonometry is, right? When we do all this stuff. So what I want to do is first show you how this actually works, how we can actually find the sine of any angle using this unit circle, right? Because we know and we've established that whatever this angle is, whatever some angle that we draw, okay? We draw some angle. I don't know why I still have trouble. We draw some angle, and we always start with our initial side here. We just draw some angle here, okay? Wherever this meets, and as our x and y value, we know the x value will be the what? What will the x value be, and what will the y value be? So this angle, whatever that angle is, right? Who knows what it is? It could be 32 degrees. It could be 28, whatever. I don't know what it is. But the cosine of that angle will be the x value, right? And the sine will be the y value. Okay, we've talked about that before. Okay, so let me give you an example. Let me erase this. What if I were to draw a 60-degree angle? Okay, we know something about the 60-degree angle. Right? I'm going to draw a 60-degree angle again at the origin. Here's my initial side, right? And I'm going to draw a 60-degree angle. Now, I got a handy tool here where I can actually use this protractor and find where we're at 60 degrees. Okay, I'm going to draw a 60-degree angle approximately right there. So hard to make it perfect. So say I want to draw this 60-degree angle right there. Again, I'm going to make a line. And here's my 60-degree angle, right? So let me move that over for now. There's my 60-degree angle. It cuts the unit circle. It's 60 degrees here, right? We just measured it. Gosh. Just measured this angle is 60 degrees. And it cuts through here at an x value. Look at that. Cuts through here with an x value. Right here. Look at where that x value is. 0.5. Okay. Now, why is that x value 0.5? Well, look at that triangle. What kind of triangle is that, right? What kind of triangle do we have here? This triangle right here. That's not what I want, is it? How do I go back? This triangle right here is this triangle right here is what kind of triangle? That's a 30-60 right triangle, and we know this small side of the 30-60 right triangle is 0.5. Okay, and well, we knew that, right? I had you guys memorize the 60-degree angle, right? If this is the 30, this is half of the hypotenuse. This side is half of the hypotenuse. If we flip it around 60 degrees, this is half of the hypotenuse. So the cosine is a half. Now, of course, the sine is square root of 3 over 2. Now, what's the other good part of this, right? Square root of 3 over 2 should be the y value. So if I just follow this over, if I draw this straight across, it's not being nice to me, is it? If if I draw this straight across, that should be meeting my y-axis somewhere around square root of 3 over 2. Now, pull out your calculator and see what square root of 3 over 2 actually is. Square root of 3, make sure you close the parentheses on the square root of 3 if it gave you parentheses, right? Square root of 3, because you got to divide that by 2. You got to make sure you close the parentheses, otherwise, boy, my calculator is not working very well. Square root of 3, I've got to move to the right. I've got a different calculator here. Divide by 2, 0.866. Well, that looks about right. I mean, you can see this side here actually, this line that I made was a little bit too high, right? I should have been closer to like there. And you can see it's a little bit above 0.85, right? 0.866. So you can imagine that's a pretty good approximation we can get for the sine just by drawing a line straight across and approximating where that is. You might have approximated it as 0.85, 0.87. Okay, so 0.86 is a pretty good approximation for the y value, which is the sine of 60 degrees, right? Okay. Now, we're going to use this unit circle. We're going to come back to it many times while we do these problems, okay? So let me erase this. Oh, gosh, I don't know why. Erase all this. We're going to go down here, and we're going to do one of these problems. I'm going to hide the ruler. Now, for these problems, we're kind of going backwards. I'm going to find all the places, right, where the sine is equal to 0.3. And we're going to do it in different ways. So sine of 0.3 actually has two different places, right, where sine is equal to 0.3. So let's go back up here. And on our unit circle, let's find where the sine is 0.3. Now think about it. What did I tell you is the x, and what did I tell you is the y values on the unit circle? Right? The sine is the y value on the unit circle, where an angle touches the unit circle. So again, if we start with our initial side here, okay, and we draw an angle, and it has a sine of 0.3. That means what? That means the y value is 0.3. That means this angle, wherever it is, has to cut through and have a y value of 0.3, right? So I'm going to follow 0.3 over and see where it crosses the unit circle. And it also doesn't just cross there, it crosses over here. Y value of 0.3 is also over there. So I've got two angles defined, right? I've got this angle, right there. Whatever this angle is one of the angles that gives me a sine of 0.3. And then I'm going to use blue for my other one. Okay, again, my initial side is here. Oh, I don't like that at all. Sorry. My initial side is also here, right? And it rotates now all the way over here so that I meet this point, right, from the origin, reaching all the way over there, okay? Didn't draw it straight for me. So from here, keep some of these things I'm just getting used to. From here all the way to here. And again, sorry, I got to keep going back to my line tool. So that's my other angle, right? This angle right here from the x, positive x direction, rotate it around, whatever that angle is. It's a pretty big angle, right? There's only a little bit less than 180 there, okay? Now, I want to actually find the measure of that angle, and I'm trying to find how much this angle is, so I can go ahead and use my ruler, right? And in class, we're going to use a protractor to actually measure these angles. Okay, so here's 0, right? Here's 0. And I'm going to rotate it and get to measure this angle. so that it crosses right there.